today's lesson is normal distribution. Normal distribution. Now, what is this normal distribution? Now, we give a test, right? And we get the marks. Like this. And then we get the total and this is the summation x, and we divide this by number of students, right? That will be our x bar. Okay. Now we'll go through this again. We give a test, we get marks, we calculate the x bar, the average, right? We can see that here we'll say the marks. This is the average, right? We'll say our average is 60. Here we put 60. That's the average x bar. Now, if we study the distribution of the marks, how the marks are scattered, we can see that the majority of students are around the average, right? Now, our average is 60. We'll say Amali got 60, Bimali 60, Dimali 60, Emali, Bimali, Jimali, Himali, right? 60. And then some will get 59 also. 59, then 58, then 57, and also now 60 now, then around the average. So 60, 61. Some students, right? These are students. 62, 63, 64, like this. We can see. Then 60s, 70s, 80s, 90. Here also 50s, 50s, 40s, 30s, 20s, and 4 or 3, something like that. When we study the distribution, we'll be able to see the shape will take like this, right? The majority of students getting the average or around the average. If it is 50, then 49, 48, 47, then 51, 52, 53, like that. Majority, here the majority, these are students. Majority are around the average. A few students will be with high marks and a few students with low marks. So this distribution is called as normal distribution. Normally, we see the majority will cluster around the average. A few students will go to the other end with high marks and a few will be with low marks. The other students are here. That is the normal distribution. Now, we make use of this normal distribution to calculate the Z score. Z score. You are familiar with this Z score. Okay. We calculate the Z score with the use of this normal distribution. Okay. Now, Z score is a derived score. Derived. Derived. Derived score. What do you mean by a derived score? We take this Z score from the raw values. Raw values. For 60, 59, 58, 36, all these are raw values. By making use of these raw values, we calculate another type of score. Those scores are called derived scores, right? And one of these derived scores is the Z score. Now, already you know another derived score. That is, can you remember the percentiles and percentage ranks? Those are also derived scores. Now, how do they become the derived scores? Now, when we get the, can you remember the marks are here? Then the frequencies, cumulative frequencies, PCFs, right? The marks, we take the marks, the upper real limits, and lower real limits. Remember, we take only the upper real limits, and also we take the PCFs. And then we calculate these P's and PRs. Those are called derived scores. Derived. Right? We get the marks here, 77.52, something like this. So from these raw marks, raw values, we calculate these PCFs and all, and then get another type of score. That is called derived score. So P percentiles and percentage ranks are derived scores. Just like that, we can get the normal Z scores also. Right? Z scores also, they are called derived scores. Now, what are the uses of derived scores? We'll say we can know one's position within the group, right? The one's level of achievement. And also by getting the derived scores, we can make fair and accurate judgments. Fair and accurate judgments. Remember all these now, first paper questions. The uses of derived scores. We can make a fair and accurate judgments. For example, now we say we have 20 tabs or laptops. Okay. And we want to give these to the students. Now in one school there are 2 streams and 2 classes. We'll say arts students are there, 1 class, and math students. Example, right? Math students combined, physical science class. And now we want to give these 20 tabs to the students who have performed well. So we take the raw marks, we give tests and get the marks. Now the art stream students, this class, they have got, we'll say 90s, 80s, 70s, 80s, 90s. Then some will get 60s also. If we take this maths class, what are the subjects? Maths class, combined maths, physics, chemistry. So the highest mark may be 50. 50s, then 40s, 30s, 20s. Right? Now, if we consider the raw marks, these are the raw marks. Now, these students, the math students, will they get the chance to get these tabs? No, because here, if we consider the marks, right? Only the art students, they have scored high marks. It can be the other way around also, right? This is an example. So it is not fair. That is not accurate also. How can we judge, right? So to make fair and accurate judgments, we convert these into say percentage and percentage ranks. Here we get the marks, just like we get the upper real limits of this art stream, and we get the PCFs, right? Art stream. Here also we get the upper real limits, and we get the PCFs. Then from these we can say the highest 25% will get the tabs, right? The highest 25%. So from this class also the highest 25% will get the tabs. From this class also the highest 25% will get the tabs. So then we can make, by when we, these are the derived scores, from these we can make fair and accurate judgments. Like that, we calculate the Z score to make fair and accurate judgments. We consider the stream or the subject. Within that subject, within that position, stream, what's the position a child gets? That's the Z score, right? Then we can make fair and accurate judgments. We can do the comparisons, all these things. Now we'll study this normal distribution. Okay. Now you can see this is the normal distribution. What is normal distribution? When we study the distribution of marks gained from a test, we can see that the majority of students are clustering around the average, and a few students will go to the higher end, and a few students will score low marks. So that's the normal distribution, right? It is not always like this, right? We'll come to that later. So when we call this curve as the normal curve. Normal curve. And there are certain things that you can study. You have to remember also. This is the line. Can you remember? Can you see in blue? We call this as X scores, row scores, right? Row marks, X marks. Here, this is the average according to our example. We put X bar. And you can see there's another scale, Z scores. Here, above these X scores, row scores, we can write the Z scores. I'll come to this later. Right? Then we have the curve. From this, now you can see Z scores are there. Sorry, Z scores are there. Row scores are there. From these scores, we can calculate the Z score. If we know the X bar, and if we know the standard deviation, and if we know a particular student's mark, then we can find the Z score. All right. Now, when you go through the questions, you can see in the normal, the question related to the normal distribution, you can find they give the standard deviation. You don't have to calculate. Don't worry. They give the standard deviation. Not always 10. According to this example, it's 10. A very high standard deviation. And X bar is also given, mean. They give the mean. And also they give the number of students who sat for the test. These three components are, these three features are given information, right? That's one way you can identify a problem related to this normal distribution. All three should be there to do the calculations. All right. Now, what is this standard deviation? If we take, we'll say chemistry, the subject chemistry, A-level chemistry. So the standard deviation means we get the marks, chemistry marks of all the students in that batch. We'll say 100,000 students, 1 lakh, Lakshya lamai chemistry. So we calculate the standard deviation. We have software, right? We don't calculate these things manually. Computer has done. So we get the standard deviation for chemistry, and also we calculate the arithmetic mean for chemistry. We get all the chemistry marks and divide that by number of students, and we get this one, computer, right? And if we know Amali's chemistry marks, they pay paper mark, paper mark, we can get the marks. And so Amali got, we'll say 70. They will give this. They know, we know this, and we know this one also. Amali is 70. We can apply Amali 70 here and get Amali's Z score. This Z score is related to chemistry. Now, what about your Z scores? You also have Z scores now. Now, this Z score is related to one particular subject, right? Now, your Z score is like this. Say, math stream, combined maths. Then, what are the subjects for combined maths? We get Z score for combined maths, right? Then we get the Z score for, we'll say, physics. Then we get the Z score for chemistry. Then what do? We get the total of these three Z scores and divide that by 3. Then you get one Z score. That is the one you have now, right? Some may get 1.36, right? Some will get minus 0.34, like that. So these, whatever the Z scores you get, those are the average of the subjects. Now, what we calculate here is for one particular subject. Okay. So, by calculating this Z score, we can know one's position within the group. According to the Z score, we can know that child's performance within that group. If it is chemistry, within that chemistry subject. If it is Buddhism, within that the Buddhism subject, right? If it is econ, within that particular subject, right? What's the position? Then we can compare the Z scores. We can select. We can, as I said, we can make fair and accurate judgments. Then, if we know the mark, we can select. We can get the cutoff mark for a grade. Then we can know the number of students who have scored that grade. There are many uses. Okay. Now, if we study this one, Z means the standard score. Another name for Z is the standard score, Z score, C score, normal score. All these are Z score, right? And here X means the row score. At the exam, they will give this to you, right? MCQs also. They will give this and you have to calculate this Z score. Then X bar means the mean of the whole group. Mean of the whole group. SD means the standard deviation of the whole group. Whole class, maybe whole group, maybe subject. That's the. Now we'll go to this one. As I said earlier, we can study the marks as this. The marks are normally distributed, right? Then there are 6 assumptions. Assumptions mean not guesses. We assume certain things. Upakara. We assume. We make our judgment based on these ideas, right? One is we can say the curve takes a bell shape. The normal curve takes the bell shape. Actually, the bell shape is like this. Bell right? The bell shape. But for the purpose of these I want to show you all this. So I drew it like this. You also can draw it like this. So here the curve takes a bell shape. That's one assumption. Remember these first paper questions. Second one is it has a symmetrical form. Symmetrical. Here from this both sides are equal. Symmetrical form. Symmetrical form. Third one is the x bar. X bar, that means the mean. And remember the mode and also the median. All three take the same value. That means x bar equals 60, mod equals 60, median equals 60. That is also one assumption. Usually it's not like that. So all these things are based on assumptions, right? Based on assumptions. That's why we can't judge people's knowledge based on their results. Because here, if we consider the Z score, we make these, we get these Z scores based on assumptions, right? So they are not always true. Anyway, here that is the third assumption. Now, what are the assumptions so far? The curve takes a bell shape. It has a symmetrical form. The the mean, mod, median take the same value, or x bar equals mo equals md. That's the third one. Then the fourth one is, now here you can see the marks. What are these? They are x marks or row scores, right? And here's the average. Now, when the average is given, I told you they give these also. The average is given, standard deviation is given, number of students is given. So once you know the average, then go to the standard deviation. Standard deviation is 10. So it's a rule, right? Normal distribution, we are using a ruler. Now in the percentage ranks, what's the ruler? 0 to 1. Sorry, 0 to 100. Percentiles, no? That's that according to the percentage and percentiles, the ruler is a 100-point scale. 0 to 100. Here, there are 6 parts, only 6 parts. Percentiles, the ruler is a 100-point scale. 0 to 100. Here, there are 6 parts, only 6 parts. Here, 1, 2, 3. 1, 2, 3, 6. Now, when we studied there are 4 standard deviations. According to your syllabus, 3. Right? That's the ruler. Right? In this ruler, you can see there are plus values, there are minus values. Z scores, right? Not the row scores. Z scores. Plus side and minus side. Plus side, minus. How do you decide the plus side? Now you have the average here 60. So average, when you get the average mark, your Z score is 0. Remember, when you get the average of that group, average mark for chemistry, the average is 60. You also got 60. Then your Z score is 0. Right? According to the formula. And then the standard deviation is given a 10. Then there are 3 points. How do you get the 3 points? You add them. 60, that's the mean. 70, 80, 90. And we consider this 90 as the highest mark. Right? All these are assumptions. Then here, this is the minus side. ළමයි අඩු ලකුණු ගත්තා. Then 50, 40, 30. We consider this as the lowest mark. Alright. Then first paper question. Sometimes they might ask, they will say the average x bar is 60, standard deviation is 10. That's all they will give. They will ask you to calculate the range. Remember the range? What do you mean by range? Range equals highest minus lowest plus 1. So what's the highest value here? 90 plus lowest 30. Not plus, minus. Then plus 1. So it is 61. The range is 61. Now tell me, x bar is x bar, no, sorry. Yes, x bar is 55. Standard deviation is 5. What is the highest value? X bar is 55. So 3 standard deviations, 55, 60, 65, this one 7. Then this side 50, 45, 40. This is the lowest, this is the highest. So highest minus lowest, that's 30 plus 1, 31. That's the right. Quickly we have to do. I'll give you quiz also after this lesson. You have to do. These are first paper questions. Right. I'm teaching you everything now. These are not difficult. Okay. Go through this video 2 or 3 times. So far what we have done, we are going through the assumptions now. So first assumption, the curve takes a bell shape. It has a symmetrical form. Third one, there are 3 standard deviation. No, third one is x bar equals mod equals median. Fourth one, there are 3 standard deviations above the mean and 3 standard deviations below the mean. Right? So remember this: the average. If you get the average, then your z score is 0. When your z score is 0, that doesn't mean you scored 0 marks. That means you have scored the average mark. That's also one of the first paper questions. When your z score is 0, that means you have scored the average mark of that group. Then above the average, you get plus values. If your z score is 0.56, is it plus or minus? It's plus. So that what's the meaning of that? That means you have scored above the average. Right? It's somewhere here. 5, 6 somewhere. Then your average z score is minus 2.3. How would you interpret this? You have scored below the average. Below the average. Minus 2.3. Somewhere. Right? That's the way you interpret the z score. Plus and minus. When you get plus marks, that means you have scored above the average. If you get a minus mark, that means you have scored below the average. If you get 0, that means you have scored the average mark. Okay. Next one, number 5. The curve does not touch the x-axis. Here, the curve does not touch, if we consider this one as the x-axis, it does not touch the x-axis, right? It goes to the infinity, anantema. It doesn't touch the x-axis. What do you mean by touching it? Here, now it touches. This it touches. This is wrong. That's not the assumption. What's the assumption? The curve does not touch the x-axis. Gap does not touch the x-axis. Remember polygon and all? The polygon should touch the x-axis. Then another assumption is within the area the whole population is represented. Within the area, the whole population. That means all the students are represented under this area. This area is students. These are marks. Remember, row marks, Z marks, right? Z scores, row scores. These are marks, and this area, within this area, the students are. Actually, I'll tell you now itself. There are two types of questions from this normal distribution. They will give you the number of students and ask for the cutoff. Or they will give you the cutoff mark. They will ask number of students. Now, for example, those students who scored above 80 will get A passes. They will give you the mark. 80 above A passes. Then they will ask, how many students will get A passes? They will give the mark, or they will give the mark and ask for the number of students. Or they will give the number of students and ask for the cutoff mark. Example, 33% of students failed the exam. Now, where are the students here? 33%, somewhere here. Fail na me pattene, minus pattene. Fail the exam. What is the cutoff mark for pass? They will give the number of students and ask for the particular mark. Those are the two types, right? So, within the area, the whole population is represented. If there are 100, according to this example, 1,200 students are here. We assume that 600 students on this side, 600 students on this side, minus side. That's the way. That's why we say it's 0.5 or 50% of students this side, 50% of students this side. If there are 1,000 students, then what? 500 students this side, 500 students this side. Right? That's symmetrical, that's why. Then another one, the probability under the curve is 1. We are studying the probabilities. Probabilities means we get up to 5 decimal places here. Sorry, 4 decimal places, right? Including this. These are called probabilities. Here we are, in your note, you can see these are given in percentages. Right? We have to get them into decimals like this. Now, the whole population is represented by this one, and the probability is 1. So 1, then this half 0.5, 0.5. That means 50%, 50%. Right? That is also one assumption. Last one, Z is normally distributed with mean and standard deviation. 0 mean and 1 standard deviation. Here the gap is 1. The difference is 1. 1 by 1. So, I have given you a note. You can go through it. You can understand. You will have to remember at least three assumptions. At least. Right? 3 assumptions. So, what are the assumptions? We'll go through this quickly. The normal curve takes a bell shape. It has a symmetrical form. x bar equals mode equals median. Then there are three standard deviations above the mean, three standard deviations below the mean, and then the curve does not touch the x-axis. The probability under the curve is 1, and the whole population is represented under the curve, in the area under the curve, right? Those are the assumptions. Now we'll go to the calculations. Go through this video 2 or 3 times. Before going to the calculations, I'll finish some theory parts, right? Now if you take this one, this is a normal distribution. The shape is like this, bell shape, symmetrical form, and you can find the mean, median and mode here in the same place, right? All these three values take a similar value, say 60 maybe. And we know that this has a symmetrical form, so 50% of students, we assume, that have scored above the average 60, and 50% of students have scored below the average. If we give a test, half of the students will score above the average, half of the students will score below the average. But does that happen in day-to-day life? No, right? Sometimes we can see this, but sometimes we can't see it. Now if we go to this one, we can see in this curve, this is the plus side. That means above the average. This is the minus side. Many students are on this side, the plus side. That means many students have scored above the average. Or many are on the plus side, and a few students have scored low marks. This means the test is easy, right? Easy. And here you can see a few students on the negative side. So we call this, there's a slant, right? There's a slant towards the negative side. So we call this one as negatively skewed. Negative skewed. S-K-E-W. Skewed. Skewed. Right? Negatively skewed. The curve is negatively skewed. When the how to pronounce this one? If it is in Sinhala, whether there's the word like this, skew. But if we go to the phonetic script, S-K, you know this, I think, by now, the phonetic script. Skew, right? Skew and skewed. So if the curve is negatively skewed, what are the things we can assume then? The test is easy. Test easy. And then many clever students. Right? And another thing, very important thing, now always this line, the highest line is the mode. A large number of the mark that is scored by a large number of students, right? Amal, Bimal, Simali, all the students are on this. That is the mode. If the mode is here, it can be 60 according to our example, right? And remember, the x bar is always on the slanted side. So here we can mark the x bar. And in the middle of the x bar and mode, you can find the median. Right? According to this one, x bar, mean, mode, median. They all at the center. According to this negatively skewed curve, x bar is on the slanted side. Here, x bar, then median, then sorry. In this one, how would you interpret? Majority of students have scored low marks. Here, the bulk is here. The bulk is here. So majority have students have scored low marks, and a few students have scored high marks, right? So we call this one as what then? Positively skewed. Positive. Positively skewed. Why positively skewed? Skewed in the slanted towards the positive side. So positively skewed. But here the test is difficult and many weak students. Though the word is positive here, many weak students are there. This one is here, slant. So when marking the x bar, where do we have to mark the x bar? Here. In this con x bar, always mark the x bar on the slanted side. You don't have to mark this. And in the middle, you can find mod. Sorry, MD. In the middle, right? Those are the things that you will have to remember. What? In the normal distribution, 50%, 50% are on both sides. But it's usually the situation is not like that. We can find many students have scored high marks in a particular test, and we call that one as a negatively skewed. But and the x bar is here on the left side, right? In the middle, you can find the median. And in the positively skewed curve, you can find many weak students. The bulk is here. Many weak students, and here the x bar, right? Right, so that is one part here about the skewness. How to pronounce this? Skewness. About skewness. Right? Positively skewed, negatively skewed. Right. Next one. You don't have to mark all these, right? They just ask about the X bar and all, and the students' performance. Negatively skewed, that means clever students. Test easy test. Positively skewed, weak students. Many weak students, difficult test. Next one, ISD. Cumulative probabilities, right? Now in the curve, I said it's a 6-point scale. 6 point, not 100. 3 standard deviations above, 3 standard deviations below the x bar. Here this is x bar, maybe 60. Right, according to our example, standard deviation is 10. Right, 60. Here 70, 80. This one 9, 50, 40. This is our x bar. Right, and I said there are 3 standard deviations above the mean plus, and still 3 standard deviations below the minus. Now the probability under this curve is 1. Here this side 0.5, this side 0.5. Or 50% of the students have scored above the mean, 50% of students have scored below the mean. Okay. Now these are the standard deviations, points in the rule. We can say among these 50%, the majority are around the average. So we can say 34.13%. You have to remember these percentages. 34.13% they come between 0 and 1. Then 13.59%. 13.59% here. 1 to 2. Then 2.14%. 2.14% here between the second standard deviation and the third standard. Then the very few 0.14% here about. So if you get all these values, you can get the total as 50%. And since this is symmetrical, here also you can find the same value. Then what is this one? 34.13%. Is it negative? No, only these Z scores are negative. Standard deviations. Right? Here, this one is positive. Here, what's this one? 13.59%. Here, 2.14%, 0.14%. I have given everything, right? You have to copy down these things. Now, what are the exam paper questions? They will ask for ISD. What is the ISD between 0 and 1? Is it equal 0 and 1? What is the ISD? Now, what is this ISD? ISD means accumulation. All you have to do is make it a round number. Don't have any decimals here. Now, what is 34.13%? What is the round number? 34%. That is the ISD. Right? 34. The round number. Now tell me, what is the ISD between Z equals -1 and +1? Z what? -1 to +1. What is the ISD? So -1 to +1, that means you have to add these two together. 34.13 plus 34.13. What is that? 6286. That is the probability, right, between these two. Now, what is the ISD? The round number. 68. 68% is the ISD. ISD means cumulative probability. Then what is the ISD between -3 and -1? -3, -1. So -3 to -1. You have to add these two together and get the rounded number. Okay, that's the ISD. So ISD means you have to get the round it up and you find the gap. You have to remember this side, right? 34.13, 13.59, 2.14. That's not that common, but at least these two you have to remember. All right. Calculate, or we'll do the problems related to Z score, right? Now there's a question. You'll get questions like this in the first paper. Okay. Ravi's math score is 63, right? So X is 63. The arithmetic mean of the distribution is 53. X bar is 53. And the standard deviation is 7. SD is 7. So the question is, what is Ravi's standard score? Right? Standard score. Give me another name for this standard score. Normal score. Z score. Alright. So now we'll find what they have given. Ravi's math score is 63. So X is 63. Then arithmetic mean, X bar is 53. And the standard deviation is 7. SD is 7. Right? Now the other day I told you to identify this problem, usually they give this N also. Right? N, we'll say 1000, something like that. But this is not the second paper question. This is the first paper question. So sometimes you don't get N. To do the calculations problems in the second paper, you need N, right? Those three information. Now, this is what they have given, and what's the question? What is Ravi's standard score? So, standard score means Z score. You have to find the Z score. So, what's the formula for Z score? Z equals X minus X bar divided by SD. I explained these things earlier, right? Remember, it is X minus X bar, not X bar minus X. Then the answer is wrong. Always remember X minus X bar, right? Remember like this. ගෙයක් හදනවා. ගේ හදනවා. හදපු ගෙට වහලේ දානවා. ගේ හදනවා. හදපු ගෙට වහලේ දානවා. Okay. How do you say that in write it in Sinhala? ගේ හදනවා. හදපු ගෙට වහලේ දානවා. X minus X bar. In Tamil, வீடு கட்டுற. கட்டிய வீட்டுக்கு குறை போடுற. வீடு கட்டுற. கட்டிய வீட்டுக்கு குறை போடுற. X minus X bar. Write those things in your mother tongue. Then you can remember. Otherwise you will make mistakes. Right, that's the formula now. Now we'll apply the values. What is X? X is the given mark, the row mark. It is 63. 63 minus X bar is 53. Divided by standard deviation is 7. So 63 minus 53, it's 10 divided by 7. Always get 3 points, 3 decimals and round them up, right? The answer here is 1 for 30, 4, 22, 14 or so 60, it is 8. So what's the answer? Z equals 1.43. Get to 2 decimals. That's the answer. Z equals 1.23. So calculate the third decimal and get into 2, right? Because you'll have to get used to this, because when you are using the normal distribution table, you have to have 2 decimals, right? Usually that's the way you do. All right. So this is Ravi's standard score, 1.43. All right, now it's a plus 1. How can you interpret this? It's a plus value. That means Ravi has scored above the average one. Average value. It's shown here. Average is 53. Ravi's mark is 63. So we know Ravi has scored above the average. And also according to the standard deviation, it's 1.43. Right? Now here it is 53. Standard deviation is 7. So what are the values? 1, 2, 3, no? 53, no, 50, yeah, 50, 53. Then 7, 60, 66, then 73. Likewise here also. Now Ravi's one is 63. Somewhere here. So according to the standard, the score is 1.43 is its score. Okay, right, that's the way. Now we say that's Ravi's one. Dinu has scored. Dinu's mark is, row mark is 23. Now we have to find Dinu's what Z score. Right, we'll do it. Z score. Write the formula, and now x is 23. Minus 53 divided by 7. Then what is this one? Minus 20 divided by 7. Don't forget about the minus value, right? So calculate this and you can get the answer as minus 2.857. 857. So the final answer is minus 2.86. Right? So here it's minus. How can you interpret? Dinu has scored below the average mark. That's why you get minus 0 value, minus Z score. Right? And she has scored very, at the very low end, because minus 3 is the lowest mark. She is closer to the lowest mark. Dinu, 23. Now we'll say Kuma. Kuma has scored 53. Kuma's mark is 53. Now we have to find Kuma's Z score. The formula is this, and here we put 53 divided by 7 SD. Here the answer is 0 divided by 7. Final answer is 0. So how would you, that Z equals 0. How would you interpret this? Kuma has scored the average mark, 53. Here you can see from here also, 53, 53. We can't say Kuma has scored 0. Kuma's Z score is 0. That means he has scored the average mark. Suppose the X bar is 83 and Anusha has scored 83. What's her Z score? 0. Right? Like that. Another question. X bar is 60 and Amali's Z score is 0. What is the mark? Amali's mark? It's 60, because Z equals 0 means this child has scored the average mark, that is 60. Right? All these are first paper questions. So you must, everybody, all of you must practice these, right? All these are first paper questions. Not difficult. Now we'll say, take this. Sometimes you get this type of questions in the second paper also. This is not a first paper question, right? This is a second paper question. One type of normal distribution problems. Amas and Renu's marks are given for maths and science, right? And the X bar for maths and SD for maths, they are given also. Here also mean and the standard deviation for science are given. So the question is, what are the positions of Amas and Renus according to the row scores? First one is positions, places, ranks according to the row score. Second one is positions according to the standard or Z scores. Those are the two questions, right? According to the row scores and according to the standard scores. So when you get a question like this, they will give like this, right? And now we have to find to get the positions here, to get the positions to rank, we have to get the total. According to the total, we can rank the students. If there are 10 students, we can get the totals, right? And then by considering the totals, we can rank them first, second, third, fourth, likewise. Now to get the totals, you will have to do it horizontally. Remember, horizontally. Some of you get the total vertically. That will be maths total. Subject taking first, second, third, and then. Now in a grade 7 class, if we select the first, second, third places at the year-end test, you get Ama's subjects and get the total. Renu's subjects. Bimali's subject, all the subjects and the total. So you get all the totals here. Then you rank them first, second, third, fourth, fifth, like that in the report, right? Horizontally or across the subjects, you will have to get the total. So when you get a question like this, prepare a table like this. Then it is easy. Right. Now, this means total of row scores. Now you can get the totals. Now what's the total here? 60 plus 43. It's 100 and 100 and this is 47, right? So the total is 107. This one's total 106. Right. Now if we take the places, who gets the first place? Amma. Second place, Rain. Right? According to the row values, row scores, Amma gets the first place, Renu gets the second place. That's the first question, right? Positions according to the row score. Positions means the ranks. The second question, positions according to the Z scores. Now the marks are given, the row marks are given, the relevant arithmetic mean and the standard deviation. Those are given for the two subjects. Now we can calculate the Z scores. So you have to prepare a table like this. Okay, it's easy. The same values. Here now maths and science, we are calculating the Z score for the maths subject, right? X minus X bar divided by SD, the same. And for science also, X minus X bar. Sometimes they will give different values also. Y minus Y bar divided by SD, right? A minus A bar divided by SD. It doesn't matter. It's like this. Then now we have to calculate. What do we have to calculate? Ama's Z score, right? So the formula is this. You have to write this formula. They don't give this. You have to write the formula. Once is enough. That's why I have put the formula up there. Then you can calculate. If if there are 5 students, just put the formula here, then you don't have to rewrite it. Do the calculations of 5 students. Right? I'll give you a past paper question at the end of this one. So there you'll have to prepare a table like this for 5 students. Now we'll do the calculation here. Ama's mark, we'll take maths, it's 60. So x is 60 minus x bar, it's 55. X 60 minus 55 divided by 10, right? By 10 here is a standard deviation is 10. Then what is the answer here? 5 divided by 10. So the Z score is 0.5. Okay. And we'll calculate Ama's science, this one, Renu's maths mark, right? So X, Renu's maths mark, Renu 67. 67 minus 55, same, right? 55. Why? We are dealing with maths mark, so it's 55. Divided by 10. Here it's 12 divided by 10. The Z score is 1.2. Now we'll go to the science marks. X minus x bar divided by SD. Science. Our science mark is 47. 47 minus, the standard deviation is 48. 48, science standard. Sorry, x bar, 48. The standard deviation is 12. X minus x bar divided by SD. Here it is minus 1 divided by 12. The answer is minus 0.08. Okay, it's a minus value. Now when you get the minus value as the Z score, how can you interpret it? Amma has scored below the average in science. Then we'll calculate Renu's one. Renu got 39 for science. Then 39 minus x bar here, it's 48 divided by 12. Then minus 9 divided by 12. The answer is minus 0.75. From this also you can interpret, no, for maths, all the students regarding this example, all the students have scored plus Z values. That means they have scored above the mean value. Now, if this teacher's mark, science, the students have scored minus Z scores. That means below the average value. So you can compare two examiners or two teachers or two subjects also, right, by using the Z score. Now, what's the question? Positions regarding to the Z score. Now we have to get the positions. To get the positions, you have to know the totals. So you have to add these two, right? You have to add these two and get the answer. The answer is plus 0.42. You know how to do those things, no? 0.5 plus minus 0.08. So how to write this? 0.5 minus, it's plus 0.08. ගණන් දැන් එහෙමනේ පොඩි කාලේ. දැන් මේක 0.5 minus 0.08. here put a 0 and it's 2, and then here it's 4. It's plus 0.4. Don't make careless mistakes, right? Do everything manually, then you can get full marks. Now, similarly, you can do this one and get the answer. The answer is, it's a plus value, 0.45. Now select the first place and the second place. According to this one, this child has scored 0.42. This one, 0.45. Which is the bigger one? This. So, first place. And the second place. Now, according to the row values, Amma got the first place. But according to the Z scores, standard scores, Renu got the first place. Right? So, what's the correct one? The most correct one, if you rank according to their performance and all, this is the one. Right? Within the group, her performance. It is not always like this. You don't get the opposite of this one, is it? Then this one. Sometimes Renu's, you can get the positions 1 and 2 here also. This is just an example to show you, right? In that past paper question, not all the marks, the positions change, right? Row scores and standard scores. Only this. So this is one type of question. Right? Here you can say, when we get the Z scores, we can make accurate judgments and also fair judgments, and we can compare two subjects. Those are the uses of Z score. Right? Now we'll study another type of interpretations. Right? Now we have a table like this. The students are there, 3 students, and their maths marks and science marks are given. The row scores are given for maths and science, right? And the relevant mean values and standard deviations are given for 2 subjects. Then you have to calculate the standard score, right? We'll do one. First one is Harath has got 45 for maths. So X is 45 and X bar is 30. Divided by SD is 6. The meaning of this one is the standard deviation for it should be maths or y x maths, right? Here the answer is 45. Here the answer is 15 divided by 6. So it is 2, 12 for 30, it's 5. Answer is 2.5. The Z score is 2.5. We put 2.5 here. Right? Likewise, calculate all the Z scores for the 2 subjects. I put the answers here, but you have to calculate, right? This one 2.5. Here you get 2. For this one 3. You have to find the Z scores, right? Then here you get 1. 0. Z is 1.5. Now we'll go through our findings. I'll read the interpretation. You'll get the note. I'm going to explain it now, right? You look at the table and follow my note, what I say. The interpretation we make when we compare the row marks. The interpretations we make when we compare the row marks for 2 subjects, 45, 55. Like for 2 subjects, a student has obtained differs from the interpretations resulting from the comparison of standard marks of the same student has scored for the same subject. The idea is when we compare the raw marks of two subjects a student has scored with the standard scores of the relevant subjects, the interpretations may differ. Example, Sarath has scored 45 for maths. All right. We tend to think that he is weak in maths. 45. We think he is weak in maths because it's below 50. No, in general we say below 50 it's weak. But when we consider his standard score, what is that standard score? It is 2.5. Therefore, we can say his performance in mathematics is good within his group, right? If we study only the raw value, 45, it's kind of low. But when we consider the Z score, it is 2.5. 2.5 means very close to the, here remember this, I'll draw it here. Here 0, 1, 2, 3. This one, Sarath's maths mark is 2.5. Right, closer to the highest mark. But when we consider the raw mark, it's 45. But when we consider the Z score, we can get the true interpretation of performance within his group. That's important. Within his group. The group mean is 30. Standard deviation is 6. Within this group, Sarath has performed very well. Right? If we take Sarath's science marks, 55, which is 55, we may consider his performance in science is fairly well because it's 55 now. But when we consider the standard score, it is 1. Standard score is 1 here. This implies that his performance in science within his group is weak. Right? It's 1. Within his group, it's not that good. Right? It's closer to the average. Next one. Another factor is if we compare the raw marks for the two subjects. Now we take the same raw marks for the two subjects, 45 and 55. We get the impression that Sarath has performed well in science than in maths. Right? So we can say Sarath has performed well in science, 55, than in maths, 45. But when we consider the standard marks, these 1 for science and 2.5 for maths. When we consider the standard marks, we can see that he performed well in maths than in science. Here, 2.5. When we compare the raw marks, we can say he has performed well in science, better in science than maths. But we consider the Z scores, we can say he has performed in maths within his group better than science. Right? Now take Malit, this one. It appears Malit has shown equal performance in maths and science, 42, 45. Right? When we consider the row scores, both are more or less the same. But if we consider the standard score within his group, he has scored 2 for maths. Right? That means within his group, he has performed well in maths. Now his science marks is 45, but he has got the average mark. That's the interpretation. So we can say that by considering, when we interpret only by taking the raw values, we cannot make accurate and fair judgments within the group. But when we consider, when we when we interpret using the Z scores, we can make accurate and fair judgments. So likewise, you can interpret Jagat's marks as well, raw marks and Z marks. Right? That is one advantage. And within this group, the student's performance can be interpreted accurately. Okay. Now, what are we studying? They are studying derived scores. All right. Percentile ranks, that's also derived score. It's a 100-point scale. Now we are not going to deal with it. But we have already done that. Z scores. We know how to get the Z scores or the standard score, normal scores. Z equals X minus X bar divided by SD. By using that formula, we can derive the Z score, right, from the raw values. Third one is McCall's scale or McCall's scores, right? McCall's. Now when we consider the Z scores, you can see there are certain limitations in the Z scores. For example, we say Z equals minus 0.03. That's the answer, right? That's the score. Now, by now, you can interpret this. By this minus value, you can say that the child has scored below the average of the group. And 0.03 means it's between 0 and 1, closer to the average. Likewise. So here in this Z score, we can find the minus values, plus minus values, and also the decimals. So it's for a lay person, a normal general person, it's difficult for them to interpret. They don't understand what is meant by these minus value, these decimals and all, right? To get rid of these two weaknesses, plus or minus signs and the decimals, we calculate McCall scale. Right? Remember, those are past first paper questions. Why do we calculate McCall scale? To eliminate the weaknesses that we find in the Z score, namely the plus and minus signs and the decimals in the interpretations. Right? So this is what we are going to do now. Don't worry, these are not difficult. These are very easy. Right? Actually, we are going to do the McCall scale and the Hull scale. These two are not in your syllabus now, but I'll just show you. So these are very easy first paper questions. First paper questions means for one problem you take only about 1.5 minutes. Quickly you can do. Quickly you can calculate this score X minus X bar divided by SD. So don't worry about this, right? So we are going to do this McCall's. All McCall's scale, right? McCall's scale. Okay, the McCall scale, we have it like this: 50-10. That's the way we read. 50-10, 120. That means twice as this, 2 times. 50 it's 100, 10 it's 20. Or 500, 100. That means 10 times. 500, 100. So McCall scale is 50-10. Basically, it's 50-10 scale. Sometimes they will ask you, convert the Z score into 50-10 scale, or convert the Z score into McCall scale. Right? Both are the same, 50-10. Now, this 50-10 scale is like this. That means 50 means the new x bar, the new mean value. 10 means the new standard deviation. Don't get mixed up, right? Now remember the larger value. Now which one is the larger, 50 or 10? 50 now. 50 is the mean. ලොකු එක තමයි mean එක කියන්නේ. And the thinner one, small one is the standard deviation. Right? Small, it's standard. Right. So now these are the new ones. What do you mean by new? And then there should be something old also. Now we'll go to this. The formula for the McCall scale is this: xc equals z into SDN plus x bar n. Right? This is not difficult. What do you mean by xc? Xc means the converted x value. That's what we need to find. Convert the Z score into McCall scale. Then we have to find this one. Right? Convert somebody's mark into the McCall scale. Then there's a formula. This is the formula and here. Z means the standard score. For this we must know the standard score. There's SDN means the new standard deviation. X bar n means the new mean of the new scale. Now, they will give the question like this. I'll read. Ruan scored 64 for maths. This is the first paper question, right? Ruan scored 64 for maths. Mean of his group is 52 and standard deviation is 8. Convert Ruan's score, Ruan's apostrophe S, Ruan's score into McCall's scale, or sometimes they might ask, convert Ruan's score into 50-10 scale. Right? Now what have they given? Ruan's score is given, that is x. X is given. What is the x? 64. Then what is given? Mean of his group is 52. Mean x bar is 52. Then standard deviation is 8. Standard deviation is 8. Now they are asking you to convert Ruan's score. Convert Ruan's score into McCall scale or 50-10 scale. Right? So these are the things that we have. Now the formula is this. How do you, actually this is not a new formula. Shall I do it? Now you know that Z equals x minus x bar divided by SD. Right? And we can get like this. We won't get this x. That's the mark. No, we have to find this x. So we are going to get this one. We have to cross multiply. We can write z into SD. This equals x minus x bar. You don't have to remember this. I'm just showing. You can write it like this one. Equals x minus x bar. We need x. So we have to take this one here. So z into SD plus, when we get this one here, it becomes plus x bar, that is our x. Right? So we can write x equals this x equals, you exchange the signs, z into sd plus x bar. That's the way you get this formula. You derive this formula from this form. Alright. Don't worry about this. Forget about this. But you have to remember this formula. X equals z into sd plus x bar. Right? This is useful for normal distribution also in the future. These two formulae you have to remember. You have to by heart. Right? It's the same, but you have to by heart this. They don't. Okay. Now we'll apply these values. Here, the formula is this one. Converted x to z into sd new sd. Now, from this, what are the things that we know? Can you see? Can you check? This is what we have to calculate. Do we know z? No. We have to calculate. Do we know the new standard deviation? Yes or no? Yes. Why? Here McCall scale. McCall scale means this is the one. New standard deviation. New mean. Right? We know that because it's given. 50-10 means McCall scale means this is the new x bar, this is the new standard deviation. So this one we know. New x bar we know. New standard deviation is 10. New x bar is 50. We don't know z. But from this we can find the z value. What's the formula? These information are given here. We can find z. Z equals x minus x bar divided by st. So x is 64. It's given to one's mark. And minus x bar is 52. Divided by sd is 8. So the answer is 2, 1 divided by 8. Then it's 1.5. That is the new or that is the z value. So we can find z here. What is that? 1.5. Actually, we have to apply z here. Now that's the z score. We have to convert the marks, this one, into the McCall scale. So we'll write the formula. You don't have to write xc, but anyway, xc equals, you can write just x, right? Z into sd n plus x bar n. Now apply the values. This is what we have to find. This one is 1.5. New sd, it's 10. Plus new x bar, it's 50. Here 15 plus 50. So the McCall scale is 65. The converted mark or the McCall scale or the 50-10 scale, the mark is 65. So we don't find any. From this we can interpret, right? They just ask you to convert this one. No decimals, no minus, and that's the McCall scale, 50-10. Alright, so I'll give you some exercises like this. and you can calculate. All you have to remember is this you know. Don't say you don't, but get that given. The next one is the Hull scale. Before we go to Hull scale, we do one of these also. That is, convert Ruansko into McCall's 120 scale. Now we did 50, 10. Now we are going to do 120. It's the same, right? So what is given here? Ruan scored 64. That is x. X equals 64. Then mean is 52. X bar 52. And standard deviation is 8. Convert Ruan into McCall's 120 scale. Once again, this is the formula. So we don't know Z, but we know new standard deviation. Now what is the new standard deviation now? It's 20. Earlier it was 10. Now it's 20. And a new mean, it's 100. Right? So we know these two values. We don't know Z. So as before, we calculate Z. Z equals x minus x bar divided by SD. Here x is 64 minus 52 divided by 8. 12 divided by 8, it is 1.5. So Z is 1.5. Then you apply 1.5 into that formula. X equals Z into standard deviation plus x bar. These are new ones, right? Z is 1.5. Standard deviation, new standard deviation is 20. I told you, you have to take the smaller value as the standard deviation. Small standard deviation. Right? S. Remember, smaller value, standard deviation. So, standard deviation is 20. X bar is 100. Here it is 30 plus 100. So, it is 130. So, according to McCall's 120 scale, Ruan's mark is 130. That's the way. Right? If it is 500, 100, right? 500, 100. Same. Here you'll have to put 100 and here you have to put 500. The rest is the same. That is McCall scale. Now, Hull's scale. Hull scale. In Hull scale, new mean is 50 and new standard deviation is 40. According to McCall scale, x bar is 50, here it is 10 or 120 like that. So Hull scale, it's 14, that's the difference, right? 14. Now Hull, you can remember like this also, it's more like 4, not 4. Just, we'll just say 4. It's 14 Hull scale, right? Remember somehow. Now the same question. Ruan scored 64 for maths. X equals 64. And mean is 52. Mean x bar 52. Standard deviation is 8. Standard deviation 8. Convert Ruan score into Hull's scale. Now we are going to convert his scale into Hull's scale. Once again, the formula is this, right? And here also we don't know Z. Do we know new standard deviation? Yes. Now what is the new standard deviation? Hull scale, it's 40. So we know this. And new X bar, we know it's 50. So once again, we have to calculate the Z value. So Z equals the same value, right? X. One 1.5. So we apply this value into this and the rest. So X equals this, you'll have to remember by heart. SD plus X bar. Right. Now Z is 1.5. Standard deviation is 14. New standard deviation. And new X bar is 50. So what are the answers? 1.5 into 14. So it is 21. You do the calculation. And here it's 50. That is 71. Now, according to row marks, Ruan's score is 64. According to Hull's scale, Ruan's mark is 71. Right? So that's the way to convert into Hull's scale. It's easy. First, what you have to do, you have to get the Z score. All the things will be given to you in that case, right? Then get the Z score, go to this one and apply all the values Z score and these into this formula. You have to remember this formula and then calculate. So it won't take more than 1 minute to do this. Right? Only thing is you have to be very careful with your calculations. Don't make any mistakes because these are too easy. You can score full marks. Alright, that's the end of Hull scale. Now we'll come to the final part, derived scores. We did percentile ranks, Z scores or standard scores, normal scores, 6-point scale. Here McCall score, McCall's scores, 50-10, Hull scores, 50-14. Then we have to do 5-point scale and 9-point scale. We are not going to do them in detail. I'll just explain what are those, right? Then, yeah, we can complete the derived scores. Here, now this is the normal distribution, right? Normal distribution is known as the 6-point scale as well. Now, how do we get 6 points? Here it's 0. Then 3 standard deviations above the mean and 3 standard deviations below the mean, right? So we are going to take this one. This is the plus side. This is the minus side. Plus minus means above the average, below the average, right? Now here this corner, that's the highest marks, right? So here it's 1, 2, 3, 4, 5, 6. There are six segments. So we call this as 6-point scale also, the normal distribution. Now when we consider the 5-point scale, we take the same limits, right? Here minus 3 equal. Here plus 3. The distance is the same. But now in the normal distribution, we divide the curve, the area into 6 parts. 6 equal parts. Now in the 5-point scale, we divide the area into 5 equal parts. Right? So usually, you don't have to know this. Now there are 6 standard deviations now. Here, 6 standard deviation. We are dividing this into 5. So it is 1.2. right? Here the values went like the standard deviations went one by one. 1, 2, 3. Here we take this one as 1.2. Next one 1.2 plus 1.2. It's like this, right? It's 1.2, and then 1.2 this distance. No, so we take 0.6 here, and here 1.8. 0.6 plus 1.2, 1.8 plus this one 3. Similarly, it's minus 0.6 minus 1.8, then 3. Right? This is the principle. So we have 5 grade A or higher scorers are here on this side, plus side. Failures and lower scorers are here on the minus side. Now 9-point scale, we divide the same distance, right? What do you mean by same distance? 6 standard deviations. Right? Into how many now? 9. Then we have values like 0.25 and something like that. It goes on. You don't have to remember those things. This one, it's fine. 0.6, 0.8 plus 3. Like that. That is the 9-point scale. When you consider this, the same formula will be used. We are not going to do the calculations for 5-point and 9-point, but here the Z score is given. We know the Z score. If we want to find the relevant mark, right, then we have to get the this formula. What is the formula to find a mark? X equals what? Z into standard deviation plus X bar. Remember this, right? If you want a mark, this is the formula. And if you want to find the particular mark for this one, Z is this. Standard deviation they will give. X bar they will give. Then you can find the relevant mark. The same principle goes for this 9-point scale. If you want to find the particular mark for this Z value, the formula is this. Z is 0.25. Put 0.5 here, they will give the standard deviation, and the X bar get the relevant X value. Right? X values are cutoff values mainly. Right. So that is the 5-point scale and the 9-point scale. What you have to remember is 6 standard deviations are divided into 5. That's the 5-point scale. Now 6 standard deviations are divided by 9. That's the 9-point scale. And higher scorers are here. A grades or distinctions are here on this side. Right. That's the end of the derived scores. So do your calculations. I'll give you some exercises based on the Z score and also some MCQs on this.